In past millennia, mankind has stared up into the stars and wondered, what is out there? Why are we here? What does this mean? Aristotle was one of the first to try and imagine the early universe, believing the Earth to be at its center, and that everything else revolved around it in a set of giant glass spheres. Nicholas Copernicus challenged the Catholic Church and tried to imagine the universe as it was, not as how others thought it should be. Galileo stared up into the stars and saw wonders beyond his wildest imaginings. Myths, constellations, science fiction, satellites. These are all just ways that mankind has tried to explain and understand the universe around them, and more importantly, what their role is within the cosmos. I believe that an integral part of being human is the desire to explore, to range outwards and find new lands, new resources, with new places where we can settle and call home. This desire to explore has led us to range from island to island, from continent to continent, and now seems to have run out of new places to discover. Space, with its quite literally infinite potential, calls to us and seems like the natural next step for our explorations. Of course, I can't just jump into a teleporter and say, "Scotty, beam me up," and away I go fighting Daleks or blowing up the Death Star. We need to have an objective. And I believe that a reasonable objective for these next 100 years will be to begin shifting people and industry into space, to begin pushing the boundaries of what is possible. And a key driver for that shift into space will be our growing needs for energy. Now, if you take a look at this graph, you'll see that the world's energy consumption is predicted to rise by a rapid rate. According to the U.S. Energy Information Administration, by 2040, which is only 23 years from now, the world's energy consumption is predicted to rise by a whopping 50%, half again of what we are consuming today. By the time 2040 comes around, renewable energy sources like solar power and wind power are definitely going to be on our shopping list. And I believe that a key way to reconcile our growing needs for energy with our increasing desire to explore space will be through something known as space-based solar power, which will be the focus of this TED Talk. Now, solar power is fairly straightforward once you get down to the nuts and bolts of it, and it works the same way in space as it does on Earth. Light energy from the sun impacts the solar cells, which contain silicon metal. The silicon atoms within the metal, once exposed to light energy, release electrons, the negative charge carriers of the atom, through something known as the photoelectric effect. These electrons, if connected to a circuit via a wire, can then be used to do useful work, such as lighting up a light bulb. Now, on Earth, we receive around 350 watts of light energy per meter squared, which is, some context, enough energy to heat a small bottle of water by a few degrees in a few minutes. In space, we receive 4 times that intensity of light, which means that if we place vast space stations loaded with solar panels, we could generate huge quantities of electricity by taking advantage of the vast amount of energy streaming from the sun every second. Now, here's where we reach our first technical problem. How do we get that energy from space down to Earth? We can't just connect the satellite with the Earth with a mile-long cable. That would be impractical. No, we need to think outside of the box. And people have kind of started to think that something around the lines of this is the solution. Although maybe this is not the best way to convey that idea. I don't want to destroy the Earth. I want to help save it. I think this is a much better, yes, a microwave. So what do microwaves have to do with this? Well, a microwave is simply a high power beam of electromagnetic radiation. And these high power beams of electromagnetic radiation can then transport a lot of energy very efficiently when traveling through a vacuum, which is what space is. Space is a vacuum. So the theory goes, light energy from the sun impacts the solar panels. These solar panels convert that energy into electricity through the photoelectric effect, and that electricity is then beamed down to Earth through microwave lasers. Now, this form of energy generation has a vast range of opportunities associated with it, as well as several key challenges and considerations that we must address. Let's start with some of the benefits. First, this form of generation would have an enormous positive environmental impact, as it would lead to the increased consumption of renewable energy and the decreased consumption of fossil fuels, which would have effects like reducing pollution, reducing acid rain, and very importantly, positively contributing to the solution for climate change, as renewable energies are near zero emissions. Next, we must consider the energy. The huge influx of energy that this project would bring to its home country would be a massive economic boost, as it would lead to increased jobs, increased manufacturing capabilities, and very importantly, increased access to energy-hungry technologies, such as robotics. Finally, this project would be a peaceful way to begin discussing some of the legal and political boundaries in space. For example, a country's right to build something in space, a space station, a space hotel, or even an international treaty where countries of the world agree to take care of the waste that they generate in space, satellites that are no longer serving any purpose. However, there are several key challenges that we must also not forget for a project of this scale. Though I previously made a joke about these stations being similar to the Death Star super laser from Star Wars, we can't forget or ignore the possibility of these stations being used as satellite weapons. Microwave radiation is extremely dangerous, and if aimed at a city or a town, these stations could cause a massive amount of death and damages. Even ignoring that, the environmental implications of these stations cannot be ignored, as if not properly planned out or regulated, these stations could cause huge damage to plant and animal populations worldwide. Next, we must consider the costs and resources of this project. The biggest cost is getting the materials into space. Right now, we're building the materials on Earth and transporting them to space, which is very expensive. In the future, we would probably have to consider getting the materials from the moon, from Mars, even the asteroid belt, and transporting them to Earth, which might be cheaper in the long term, but right now is practically impossible. Finally, there are several political and legal challenges and implications that we must confront. For example, who would own these stations? Would it be a government, a corporation? If it is a corporation, should a profit be made from this energy? After all, isn't space a free resource, open to all? Finally, what are the political and legal implications of a country or a government or a corporation controlling and dominating an area of space and denying others access to it? This could be very, very dangerous. Regardless of the answers to these questions, these stations would require human technicians to maintain and repair them, and as our energy needs would grow, so too would the human presence in space, eventually culminating in entire cities orbiting the Earth, working full-time, not just to beam electricity down to Earth, but to push the boundaries of what is possible in space. But as I said before, these missions are expensive. And critics ask, is it right to spend so much money and so many resources on a project that seems to have few visible benefits? And really, ladies and gentlemen, this isn't just a question about space-based solar power. This is a question about space exploration. Is it worth it? And I say that it is. I say that it is worth it. Why? Because when mankind goes into space, we on Earth are inspired. This picture was taken by Apollo 17 astronauts on their way to the moon. And in the 1970s and 1980s, it inspired environmental movements worldwide, whose efforts today have culminated in a comprehensive climate agreement where the governments of the world have agreed to try and save our fragile blue home. The influence of one photograph. Those immortal words uttered by Neil Armstrong on the surface of the moon inspired a generation worldwide to become teachers, doctors, engineers, lawyers, mathematicians, physicists, all captivated by the promise, the allure of being something greater than they already are. Critics are right to question the costs and benefits of these projects. And I would argue that there is a practical and tangible benefit to what I am proposing today, greater and cheaper access to clean electricity. But critics rarely consider the unexpected, the unintended consequences that come from reaching for the stars. Because an investment in space exploration is not just a scientific pursuit, but an investment in the spirit, the zeitgeist of a generation. The people inspired in full or in part by space have gone on to make the world a better place. We want to go into space, not just because we want to make your electricity bill cheaper, or because we want to collect some cool rocks, but because our hopes and our dreams urge us to do so. And so the next time, ladies and gentlemen, someone asks you, why should we explore space? Just try and imagine that sense of wonder our ancestors must have felt when they first stared up into the stars. Thank you.